continue. So expand this equation by applying this to this free body diagram. Now, whenever you do some moment equation, you always have to define positive direction. Okay, positive going clockwise or counterclockwise. Doesn't matter. It's up to you. Okay, so I'm going to do clockwise positive, right? Okay, so about joint B, which force has a moment, which force creates a moment? Well, this force, this 100 Newton known force, well, it has a moment, right? Because this 100 Newton has this line of action, okay, straight up vertically. So the distance, the shortest distance between this line of action and this point, this joint B, is this distance right here, which is exactly 1 meter. Okay, so that's easy enough. So my first moment term is from this 100 Newton times 1 meter. Okay, and positive negative, well, use your right hand rule, right? So this, right, this force, 100 force, goes up, so it follows the positive direction. So, right, and the direction of this moment, right, is going into the board. Okay, but you don't have to worry about that because we're just using the magnitude. Okay, so it's not a vector. So this is positive. Okay. Next, second term, FCE. Okay, that's the unknown, right? So FCE will create a moment about point B, right? So FCE times, right, F times D. So D, the shortest distance, is this guy right here, okay, which is this length of BC. But knowing that this triangle is 45, 35, 90 triangle, so 1 meter means this is 1 meter tall, right? So BC is 1 meter, so that's 1. Positive, negative, well, according to this direction that I have assumed earlier, okay, I assume that this goes through right, this means that it will create a counterclockwise moment. So this means that this is negative moment. Okay? So that's it. Alright? These two guys, FBD and BE, create no moment. Okay? Or if you like, you can add these two terms in there. Okay? FBD times the D term, the distance, is 0. Okay? Again, FBE times, right, 0. So the moment from these two guys are just 0. So just drop them. Alright. So just crunch numbers. That's all. Alright, the rest is just piece of cake. So move this term over. So FCE turns out is 100 newtons. Okay, so FCE is positive 100 newtons. Positive means, it's important. Positive means your originally assumed direction is correct. Right? So positive means direction correct. So FCE does indeed point to the right. So now we can come back to this real picture and draw the actual direction of FCE. Okay? So FCE is 100 newtons. Okay? So now FCE going to the right means that CE member is under tension. Again, using Newton's third law to help you figure out. Okay? So CE is under tension. Okay, so now I can come back to this. So this 100 tension. Okay, so here's the general procedure. Right? So basically, this is it. Right? You apply some moment equation to some point, right? And then just expand that. and pick a good point, and pick a clever point so that it can eliminate the rest of the unknowns. Okay, let's continue on. I found CE. Let's find one of the other two. Let's see. I'm going to let's say BD or BE. Doesn't really matter. Okay, let's find BD. Okay, so this guy right here. Okay, erase this. All right. You use exactly the same free body diagram. Okay, so except now, second time, the unknown is FBD. At this point, this is no, sure, you have calculated this to be 100 newtons. Okay, so same free body diagram, trying to find BD. Now obviously, we cannot some moment about point B again, because this disappears, right? We want this term, this FBD, to survive this equation. So pick another point where FBD exists. Okay? But at the same time, this guy, FBE, will disappear. Okay? So, which point would that be? Let's see. Point A, no good. Okay? Because joint A, if there's some moment about joint A, both BD and BE will appear. They will create a moment. Okay? What about joint C? It's no good either, right? BE and BD each will create a moment. So both terms will appear in the equation. So that's no good. That's it. We're around a point. We're around a joint here, A, B, C, and none of it is good. Well, here's kind of the trick. You don't have to take a moment about a joint that you see. You can pick a joint outside of this free body diagram, okay, that you don't see. So you can pick any of the joints here in this truss, okay, that is outside of this section. Okay, that will work. That's exactly what we're going to do. So we're not going to choose A, B, or C. Well, what about E? Okay, E will be like somewhere here. Okay. If I pick joint E, look at this. FBE passes through joint E. CE also passes through joint E. So these two guys disappear right away. Okay, although CE is known. Okay, but we only really care about eliminating BE. So BE will disappear. Okay, what's left is BD and this 100. Okay, will create a moment about point E. No problem. So joint E, okay, will be a good joint to pick. Some moment about equal 0. And just to help you visualize it, I'm going to kind of draw the dash line, right? Dash line, because these two dash lines really don't belong in this free body diagram. Okay? So these three members in black are my free body. They make up my free body diagram. These two, it's just sort of temporary. Right? So that's my E right here. Okay? So that's why I use dash lines. Right? So some moment about joint E, and once again define your positive direction. I'm going to use positive clockwise again. So now just expand it just like before. So again, this 100 Newton times D, the shortest distance, about joint E now. So joint E, okay, this 100 okay, is 2 meters from joint E, the shortest distance, 2 meters. So times 2 now, positive. Okay, so next, BD, my unknown. Okay, F, BD. times, I'm going to extend this line of action. So the shortest distance between this line of action and joint E is this distance, vertical distance, which is 1 meter. So FBD times 1 meter, positive, negative. FBD about joint E will create a positive moment, clockwise moment. So it remains positive. Okay. Well, keep going. FBE passes through joint E, so it disappears from this equation. Okay. FBE creates no moment about joint E. The same goes for CE. So that's it. Go 0. Crunch numbers. So FBD equals, move this guy over, negative 200 newtons. Hey, what does negative mean? Just like before, I told you, whatever result that you get, the sign, okay, would tell you whether your assumption of this direction was correct or not. Negative means that my assumption was incorrect. This direction needs to be flipped. So in reality, this arrow right here is actually pointing to the left. Okay? Pointing to the left means, according to Newton's third law, BD member is under compression. Okay? And 200 Newton compression. Okay? It's it for BD. Okay? Simple as that. Alright? So the kind of trick here is pick a joint. Right? I've just picked a joint outside of my usual free body diagram. Okay? Next, the last force to be found is FBE. Okay? Let's look at that.